Do you see this little thing over here? It's called the unit circle. We're going to need to fill that in. Here we go. So we're going to do two things today. We're going to do some factoring, and then we're going to do some solving. So first, let's go ahead and fill in our unit circle so that we can use it later on. So this right here is, of course, the angle pi over 3. I hope you haven't forgotten the unit circle yet. 1/2 rad 3 over 2. This is pi over 4, which is rad 2 over 2, rad 2 over 2. And then, I don't know why I'm doing different colors, just for fun. And this is pi over 6, which is rad 3 over 2, 1/2. Okay. And then I like to kind of go around and fill in, this is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay? So we're going to be solving today, and it's a little bit like arc sine in a way, but it's like arctan, arc sine, which I know you guys didn't really care for, but it's actually a little easier than that. Okay? So, got that filled in? Let's go over here. We're going to factor completely and then simplify if possible. So these first three things can be factored. This right here is the difference of two squares. And the funny thing about trig, like sine, cosine, tangent, all these things, is they act like algebra. It's weird. Like this is, if you had in algebra 2, you had x squared minus 1, you can factor that as x plus 1, x minus 1. You could do the same thing here for secant squared. So this would be secant theta plus 1, secant theta minus 1. And that's it. And they want you to simplify if possible. Sometimes these can be simplified, sometimes they can't. If they ask you just to factor, then you're done. You just factor it. Okay? We're going to use the factoring in order to solve coming up pretty soon. So let's look at number 2 now. Number 2, this would be, you know, what happened? All right, number 2, this is going to be like a star method if you want to do star method, or a grouping, whichever thing you want to do. But you have to kind of think of tangent as your variable. You know, if you rewrote this in terms of like if you let y equal tangent x, then you would have 4y squared plus y minus 3. And we're basically just factoring that. But instead of y, we're factoring it with tangent. Okay? So, you know, I know a lot of you guys don't like star method, but I'm going to go ahead and use it. So I'm going to go 4 times negative 3 up top. And I leave the tangents out and put them in later. And then 1 goes in the bottom with a 4 here and a 4 there. And then to factor, I say, what times what's negative 12 adds up to 1? That would be a positive 4 and a negative 3. So 4 over 4 reduces to 1 over 1. And 4 over negative 3 does not reduce. And so now we're ready to factor. So we're going to have our two binomials. And so for the first one, I have 1 over 1. So that's going to be tan x plus 1. And then 4 tan x minus 3. And that would be completely factored. Okay? So instead of, you know, your variables like y and x and stuff, we're going to be using tangent, sine, cosine, all that good stuff. Any questions so far? We're good? Okay, for number 3, if you notice, it's not in the same trig function. We have a cosecant squared and a cotangent, and that's not good. We don't want that. So we want to change everything so that they're in the same terms. So if you look, cosecant squared, we learned the other day, cosecant squared is equal to 1 plus cotangent squared. You know that because that's one of your Pythagorean identities. Okay? Minus cotangent x minus 3. So I took cosecant squared, and all I did was replace this with its trig identity because 1 plus cotangent squared is equal to cosecant squared. And you're probably thinking in your mind, I really need to memorize those. And you really do. Yeah, you're right. All right, so now let's go ahead and simplify everything, get everything in the same order. So I'm going to put my cotangent squared first. Then I have a minus cotangent x. and a minus 2. Okay, so I combined all my like terms and put it in the correct standard order, and now I'm going to factor. And this is just a very basic, factoring problem. There's no number out front. So this is going to be cotangent x times cotangent x. That would give you cotangent squared. And then what gives you a negative 2 would be a plus 1 and a minus 2. And if you wanted to check the inside to see if everything was okay on the inside, that's a negative 2 cotangent x plus 1 gives me a negative cotangent x on the inside. And that would be it. Okay, so it's really important to be good at factoring when you get to trigonometry, because now you're factoring trig functions. All right, the second part of today's lesson, we are going to be solving. We're going to solve on the interval from 0 to 2 pi. What that means is all of our answers are going to be angles that go in a positive direction, start at 0, and end at 2 pi, but do not include 2 pi. Okay? So let's take a look. Number 4. We're solving this. This is not an identity. It's not a simplify thing. We're solving for x. We want to find out 2 sine x minus 1 equals 0. We want to find out what x values. Now there's an infinite amount of them, but we're limiting it just to the unit circle one time around. Okay? So here we go. We're going to solve like we normally would. We're going to add 1 to the other side. 2 sine x equals 1. And then divide by 2. Very good. So sine of x equals 1/2. Now what we're asking ourselves here is what angle gives me a sine value of positive 1/2. It's like doing the arc sine thing. Okay? But we're going to be on the interval 0 to 2 pi. So we're actually going to have 2 answers. Okay? So you were right. What did you say? Pi over 6? Yeah. Pi over 6. No, not negative. Where else is sine positive 1/2? All saints trust Christ. Oh, sine's positive over here. So that would be 5 pi over 6. And those are your 2 answers. Okay, so where is sine equal to 1/2? That's why I had you write the unit circle. Oh, sine's 1/2 right here at pi over 6. But then it's also positive 1/2 over here in quadrant 2. And you're like, oh, but isn't negative something? Yeah, you're right if you went all the way around, but we're only going positive direction 0 to 2 pi.
Wait, do we have to figure out what that is? Oh, 5 pi.
5 pi over 6, yep. So you have 2 answers.
Isn't it always just going to be like the reciprocal? Or not the reciprocal, but like the remainder of like...
Yeah, it's going to be, they'll be the reference angle for sure, but you have to figure out which quadrant you're in.
So
exactly.
Like you're only figuring out what quadrant you're in for like positive negatives, right?
Yeah. Okay, let's do another one. Number 5. No, you're good. Let's go ahead and add sine x to the other side to get our sine x's together. Sine x. So 1 sine x plus another sine x gives me 2 sine x plus rad 2 equals 0. Let's subtract rad 2. We're solving for sine. Subtract rad 2 to the other side.
Wait, shouldn't that be 0? Why do you have that 2 sine x's?
I added this sine x over to here. So 1 sine x plus 1 sine x gives me 2 sine x.
Okay.
And then subtract rad 2 and then divide everybody by 2. So I'm trying to find which angles give me, and these are going to be recognizable. You're going to be like, oh, okay, they're going to be our nice, unit circle numbers. So where is sine negative rad 2 over 2? Well, here's how I figure this out. I know that sine is rad 2 over 2 at pi over 4, but that's positive. I need the 2 negative ones. So I'm going to be over here at what? Someone said it. 5 pi over 4, because we're in quadrant 3. Okay, just over 1 pi. And also, is he laughing at you?
7.
He is, huh? 7 pi over 4. Thank you. Yeah, what a jerk. Yo-chan, leave him alone. He's doing great. Why don't you contribute sometimes? Shh. Okay. Number 6. I just shushed him. Contribute. Shh. All right. Any questions on that one? Do you get the idea of what we're doing? We're solving, and then we're trying to find just in the unit circle from 0 to 2 pi where those values would work. There's an infinite amount of answers. You know that, right? Think about the sine wave. Here's the sine wave. It goes like this. Forever and ever in each direction. Think about the line y equals -2. Y equals -2 goes forever in each direction too. And so you get 1, 2 answers. That's those 2 right here. But there's an infinite amount of answers in both directions. But we're just focused on 0 to 2 pi, wherever that's going to be, somewhere around there. Somewhere, okay? It's actually right here. Okay, here we go. Number 3. You want to try one? Or want me to keep going? You want to try one? Add 1, divide by 3. Tangent squared x is equal to 1/3. Okay, we'll do that all in one step. And now we're going to solve for tangent by taking the plus and minus square root. And people forget plus and minus, but you have to. If you're taking the square root, just like if you had x squared equals 16, a lot of people say, oh, the answer's 4. Well, it's plus and minus 4, right? So you take the plus and minus square root, and we get the square root of 1 is 1, and the square root of 3 is 3. And you might not recognize that, so you might want to rationalize. So tan x equals plus and minus rad 3 over 3. I think that helps a lot. I know you're not supposed to. You don't have to rationalize this time, but drugs already. All right, so you know where rad 3 over 3 is. Where is it? At all the pi over 6's. Yeah, because I taught you that trick, right? That someone else taught me. That if there's 2 3's, then we get pi over 6 for tangent. Okay, but I have plus or minus, so guess how many answers I'm going to have? 4. All the positives and all the way around. All the pi over 6's, right? Because tangent's positive in 1 and 3, so I need those. But then I also need the negatives, which are in 2 and 4. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. 4 answers to that problem from 0 to 2 pi. Any questions so far? We're doing okay?
Where did you get the plus and minus right there?
Ooh, so this is, tangent is squared. So basically I had to take the plus and minus square root of both sides of the equation to solve for tangent. It's like if I was solving that, I would have to do x equals plus or minus square root of 16. All right, number 7. Now, here's something that people do every year, and they're wrong every year. They want to divide both sides by cotangent. You're not allowed to, okay? You're not allowed to divide by anything that could be 0, because it could be 0, so you can't divide by it. It's kind of like this. Let me give you an algebra problem real quick. If I say x squared equals x, and I told you to solve that for me, some people will be like, oh, let's just divide by x. Okay, so x equals 1, yay. Well, guess what? You're missing 0. Isn't 0 squared equal to 0 also? So how would you solve x squared equals x? Well, you want to bring it over to the other side, factor an x out, and then you'll get your 2 answers. You get 0 and 1. Okay, that's what we're going to do with trig here. Here we go. We're going to, instead of dividing both sides by cotangent, which you're not allowed to do, you're going to subtract 2 cotangent to the other side. So you get cotangent x cosine squared x minus 2 cotangent x equals 0. Okay, so now to solve this, we're going to bring that cotangent out to the front. We're going to factor out the GCF. So cotangent x equals cosine squared x minus 2 is equal to 0. And then you want to set up 2 equations to solve. So we have 2 factors, 2 equations. All right, so we want to find out where cotangent x equals 0. And we also want to find out where cosine squared x minus 2 equals 0. Okay, so let's focus on the left one first. Where does cotangent equal 0 going around this whole thing? That's tough, right? Cotangent, tangents, those are hard. Well, cotangent is the x value over the y value on the unit circle. And where is x equal to 0? Pi over 2? Is that right? Yeah? And then 3 pi over 2. Think about the cotangent graph. It has an asymptote through 0. And then it goes through 0 at pi over 2. Can you picture the cotangent graph at all? No? It's been so long, huh? Okay, so we got those two answers. That's great. Now let's go over here. Add 2. Cosine squared x equals 2. Take the plus and minus square root. And this is here to trick you. Where does cosine x equal plus and minus rad 2? It doesn't. Okay. Did you know that all of your values along the unit circle are less than 1? Rad 2 is like 1.14, something like that. Okay, so this one has no answer to it. It's just that. And everyone's like, well, what about pi over 4? That would be rad 2 over 2. This is just rad 2. Do you recognize rad 2 anywhere on your unit circle? No. It's not there.
So
All right,
if that
yeah.
happens, what do we write?
I want to see that you're solving it, but then you can just cross it out. So your answers are just those two. All right, 2 more. Number 8. Okay, we're going to solve this. It's equal to 0. Trung, what's he doing to you too, huh? Yeah? Yo, Chung, you're just a troublemaker. You got Brett, you got Chung. You're like... Seriously. Chung, I'm going to sit you in the back next time so you can't see anyone. You'll just send them stuff still, huh? Chung, I'm watching you. Chung, you're a troublemaker. Okay, here we go. He's never been called that before in his life. All right, let's go ahead and factor. Here we go. Chung, you need to get some new friends. Seriously. You do too. Yo, Chung, I'll eat lunch with you. It's okay. All right, here we go. We're going to factor this. Do you guys need to use the star method? Or do you know how to factor this just on your own? You need star method? Okay. So we'll go 2 times -1 up top. The -1 in the bottom. 2 and 2. So what times what's -2 adds up to -1 would be a -2 and a +1. So on the left side of this star, this will reduce to 1 over -1. And the right side is just 2 over 1. All right, so you factor it, you leave out all the signs and the sign squares, you ignore them. You just look at the coefficients, 2, -1, -1. You factor it normal. Now you put the signs back in. So I have 1 over -1. So I'm going to have sine x minus 1. And over here, I have 2 sine x plus 1. Okay? Everybody with me? All right, so now let's set up our 2 equations to solve. I'm going to go and solve sine x equals 1. So sine x minus 1 would equal 0, so I'm just going to add 1 to the other side. And I also need to solve sine x equals -1/2. Good. And I hope you can do that part in your head. You're just subtracting over to the other side and dividing. So now we have to find out where is sine equal to 1. Well, that would be where the y value equals 1. And there's only one spot, right? Pi over 2. Perfect. Good. X equals pi over 2. So that's one of my answers.
2 answers?
No, not necessarily. When it's 1 or -1, there's only one answer.
Okay.
Yeah. I think about the sine wave. And from 0 to 2 pi, it only equals 1 once, and it equals -1 once. It doesn't have 2 answers. But if I'm looking for 1/2, see how sine equals 1/2 here and here? That has 2 answers. So, all right, and then where does sine equal -1/2? That would be at where? Ooh, not pi over 4. Pi over 4 is where it's equal to rad 2 over 2. So it would be at what, pi over 6? So it would be 7 pi over 6, quadrant 3, and 11 pi over 6, quadrant 4. Good. So you get 3 answers for this one. Okay, last one. Number 9. 2 sine squared x plus 3 cosine x minus 3. Now, you have too many things going on in this problem. There's sines and cosines, and what we're going to do is just like that one factoring problem that we did up there, we need to replace this sine squared, okay? And I know that cosine squared plus sine squared equals 1. So I'm going to replace sine squared with 1 minus cosine squared. Sine squared equals 1 minus cosine squared. So let's replace it. We've got 2 times 1 minus cosine squared x plus, oh, that was me. I have a text message. My drugs are ready. Sprint, your payment is due. Dang it. Bills, everyone needs money. All right, 3 cosine x minus 3 equals 0. Sorry, I left my phone on because my children are sick and I sent them to school and I'm expecting the elementary school to call me to go pick them up soon. All right, Mother of the Year. Go ahead and factor or distribute that 2 in. 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. I figured you guys needed me more than they did, so. All right, so do you like a negative cosine squared term? Do you know? I don't either. So let's get everything over to the other side. So let's go with 2 cosine squared x. So I'm adding that negative cosine squared, 2 cosine squared x over to the other side. I'm going to subtract 3 cosine x. And on this side, do you see I have a negative 1? 2 minus 3 is negative 1. I'm going to add it over to the other side to get positive 1. Did I lose anybody on that step?
Yes.
I did. Okay. So see this negative cosine squared? I don't like my squared term to be negative. So I added it over to the other side. Then I subtracted 3 cosine x over to the other side. And then I have a 2 minus 3 is negative 1. So then I added that over to the other side. Okay. Yeah? Now, we need to factor. Star method if you want. So we'll go 2 times 1 up top. Negative 3 on the bottom. 2 and 2. What times what's 2 adds up to negative 3? Would be a negative 2 and a negative 1. So this reduces to 1 over negative 1. And this is 2 over negative 1. If you don't use the star method, that's fine. If you use grouping, go ahead. If you can just straight factor it just by looking at it, that's cool too. All right, so let's go ahead and put it into our factors. So we have 2 cosine x, cosine x. Oh, sorry. I got ahead of myself. All right, so this is going to be minus 1, and this is minus 1 also. I rearranged them, I'm sorry. I forgot I did the star method. I was just factoring it. So now let's set these equal to 0 and solve. So first one would be, where does cosine x equal 1/2? Ooh, we haven't had this one yet. So cosine x is 1/2 at pi over 3. And then all the way over in quadrant 4. And don't say negative pi over 3 because that's not right. Your answers are from 0 to 2 pi. They're all positive angles in a positive direction on the unit circle. So where does it equal? That would be at what, 5 pi over 3? Okay. Is anyone still struggling on like the fraction part of it all? Yeah? I always think of 5 pi over 3. I think of 6 pi over 3 as a whole 2 pi. And I want 1 short of that. So instead of 6, I need 5. 5 pi over 3. And then where does cosine equal 1? Bless you. Where does cosine equal 1? That's when the x value is 1, so that would be at 0. I also think of, I don't know if you think of this, but instead of the unit circle, I think of a cosine graph. And where does cosine equal 1? That would be at 0. So those are your 3 answers.